Hello everybody and welcome to Work Against the Grain. In this video I hope to accomplish three things for you to know. One is, how do we enter our bits into Vectric? Where do we buy the bits? And which bits do we buy? And so hang in there, let's hop into Vectric and get this party started. Okay, so here we are in a brand new session of Vectric Aspire software. And what we'll do here is, for the sake of focusing on the entering the tools and the bits into our database, we'll go ahead and come in here and create a new file. None of this matters for what we're doing right now. What we want to do is hop over here to our tool paths screen and focus right here on our display tool database. And this pops up our tool database where we enter all of our various bits. And the fine folks at Vectric have given us both a place to put all of our metric bits and tools, and they have given us a place for our imperial bits and tools. I personally continue to work in imperial measurements. I shouldn't. Metric is much more precise, but I do imperial. Just know that what we do today in entering tools in here is exactly the same as you would do it down here. Okay? So the first thing, let's focus on an end mill, because that is the easiest one we have to enter. And so we're going to come down here to the bottom and we're going to go new. And the tool type that we're going to enter is an end mill. And this particular end mill is going to be a 1/4 inch. So we're going to change this to 0.250. And I'm going to go ahead and go 2 flute upcut. And I'm going to go ahead, since I know what type of bit it is, I'm going to put 2 flute upcut. End mill. And this is default tool set defined using, this is imperial units. Okay. Now we know here D, because of this D here, it's asking what our diameter is. Now, it's not asking what our shaft diameter is. It's asking us what the diameter of our end mill is. And this matters here because when we enter a tapered bit, whether it be a tapered end mill or a tapered ball nose, those are going to be two different measurements. But for sake of this, our end mill, we know, is 1/4 inch, which is 0.250. Then this is asking us, how deep do we want to cut in each pass? There is a formula for this. As I have said before, I am no expert. I would search in Google for speeds, feeds, and cutting depths, and that will help you. I have found, for me, what works the best is on a 1/4 inch diameter tool, going half the distance or half the width, the radius of the tool as my cutting depth works the best for me. And so I'll go 1/8 inch deep. Step over means when it's making a pass, how much of the bit do you want it to move over when it makes its next pass? And so, for example, if we set that at 100%, then it would cut the entire diameter of the tool. When it got to the end of its cut and had to come back and make another cut, it would move over the entire 1/4 inch. And that doesn't work. What works for most of our end mills is a 40% step over, which in this case would be 0.1 of an inch. And so we're going to leave that there. Now we get into our feeds and speeds. This totally depends on your machine. For my machine, and one of the rules of thumb, as I have done my research, says the bigger the bit, the slower the speed. So in my particular case, for this 1/4 inch end mill, I'm going to set my spindle speed at 18,000 RPMs. I'm going to set my feed rate, because my machine will do this, at 100 inches per minute. And my plunge rate, how fast it plunges into the material, I'm going to set at 30 inches per minute. And I will set this up as tool number 1. Now, if you have an automatic tool changing machine, you could assign whatever tool number you wanted here so that Vectric would know which tool to go get. And then we have to remember to click Apply. And so here is my new end mill. I've got a 1/4 inch 2-flute upcut, and click OK. And now if I come back into my tool database, there's the tool that I had just entered. Okay, now let's get into something that's a little bit more technical. That's kind of the basics. But one of the tools that we all use is a Ballnose. And Ballnose is what, as we all know, Ballnose are the tools that we use when we're doing some 3D machining to get a really, really nice finish on our 3D piece. We use Ballnose tools. And they make straight Ballnose tools, and they make tapered Ballnose. We're going to focus today on the tapered. Let's focus on this bit right here, and there's some things that are very, very important that we know about the bit before we enter it in Vectric. On a tapered Ballnose, you have to know the shank diameter. In this case, it's 1/4 of an inch. We have to know the side angle of the bit, and we're going to utilize a 1/16 inch Ballnose, and that's the diameter of the Ballnose, not the radius of the Ballnose, and that's very important to know, as you'll see in a moment. And our side angle is 5.4 degrees. And so let's leave this here and come back up over to Vectric. Go back into our tool database, and this time we're going to want to enter a Ballnose tool. And so we're going to select New, and the tool type that we want is a tapered Ballnose. As you recall from the end mill entry, I talked about how the shaft diameter and the end mill diameter may be different, and that when we got to the tapered end mills you would see, and as you see here, our diameter D here is our shank or our shaft diameter, and if we hop back over to our precise bits, we know that it's 1/4 of an inch. And so we'll leave this 1/4 of an inch. Our side angle on our bit, as we hop back over, is 5.4 degrees. And so here we are going to enter 5.4 degrees. Now, this is where it gets a little tricky, because as we saw over here, this is a 1/16 of an inch, 0.0625. 1/16 of an inch diameter tip. But when we enter that into Vectric, it's asking for our tip radius, not our tip diameter. And so the radius, as we all know, is half of the diameter. And so in this case, it'll be 1/32 of an inch. In decimal form, that's 0.03125. Great. Our pass depth that we want to use. Now, let me back up a little bit. One of the reasons for using tapered ballnose bits as opposed to straight ballnose bits is if you had a 1/16 of an inch ballnose that was not tapered, that would mean your shaft diameter here would also be a 1/16 of an inch. And as most of us have found out, when you have shaft diameters that are a 1/16 of an inch, or say less than 1/4 of an inch, how many of you have snapped that bit right off because you fed your machine too fast? We've all done it. I continue to do it today. So, coming back into Vectric, we want to understand that on our pass depth, that whole half of our diameter as our pass depth kind of goes out the window here, because we've got two diameters. We have a tip diameter and we have a shank diameter. So in this particular case, in most cases, you're going to leave about 40 thousandths or 50 thousandths of an inch of material that you are going to remove after you do your rough cut. And so for this particular bit that has a 1/4 inch shank that tapers down at 5.4 degrees to a 1/16 ball or a 32nd radius, I'm going to put my pass depth at a 1/16 of an inch. The step over and your clearance pass step overs are how good a finish do you want on the material. Now keep in mind that we've got a 1/16 of an inch as our diameter, 32nd radius. This percentage here is every pass that it makes, how far is it going to step over before it makes the next pass. The lower the percentage, the better the finish. For me and my machine, I have found that anywhere between an 8 and a 12% step over works very well for me, and I get a really nice finish on my 3D model. I'm going to leave my spindle speed at 18,000, but on my feed rate here, I'm going to put my feed rate, because my machine will handle it, at 150 inches a minute, and my plunge rate at 30. We'll leave this again at tool number 1. And then one important thing that we need to make sure that we identify is did we call it the right thing? We've got a tapered ball nose, 5 1/4 degrees, with a tip of, now this is a 1/16 diameter, and I always come in here and add the R so that I know that this is a 32nd radius or a 1/16 diameter bit with a 1/4 inch shaft. But you can call this anything that you want so that you can remember which bit you're using. And then we're going to click apply. And we come over here to our bits, excuse me, and sure enough, we have our 5 1/4 degree, 32nd radius, 1/4 inch diameter bit in our ball nose toolpath. Pretty cool, huh? So that's how we enter bits into our toolpath database in Vectric. And now let's talk about some of the various places that we can go buy our bits. I never know when to cut the videos off because I have to tell you, I could have gone on for hours with the bits and all kinds of stuff. Anyway, these are the 5 places that will cover any CNC router bit that you need on the market today. Magnate, Precise Bits, MSC Supply, US Router Tools, and Tools Today. And all of these places have a great selection. Precise Bits, we'll talk about when I show you some pictures of the bits. And I'll tell you where I got all of the bits as we get to the end of this. But those are the 5 places. If you were wondering where to get bits, that's where you go. So I think we've covered 2 of the 3 things that we talked about. One is how do we get the bits into Vectric. 2 was where do we get them? And now 3 is what kind of bits do I buy? So let me show you some pictures, explain a couple of things, and then let's go make something. Okay, here's everybody's favorite, the Ballnose. These are from precisebits.com. It comes in a 3-pack. You can actually mix and match as much as you want, but here I got a 32nd diameter, which is a 64th radius. I got a 16th diameter, which is a 32nd radius that we did in the exercise. And I got an a 1/4-inch diameter, which is an 1/8-inch radius. If you get these 3 bits, you can do just about any of the 3D modeling stuff that you'd like. Get some really fine detail, really fine finish. These do have the ZRN coating. I find that you get a little bit better finish with that, and they certainly last a lot longer. So tapered Ballnose, absolutely got to be on the list. And in no particular order is the 1/4-inch end mill. I've got an up cut, a down cut, and an up-down cut. I invite you to the manufacturer's websites. All of the manufacturers that I gave you carry these. High-speed steel, coated, not coated. They all serve a very specific purpose, so I invite you to the manufacturer's websites to read up on the bits and understand what each does, when you use the up, when you use the down, when you use the up-down. I personally like the up-down the best. Seems to be a cleaner cut, especially when you're cutting plywoods and laminates. Does a very, very good job, leaves very little chip out. A very good bit. So certainly a must in anybody's CNC tool bit, tool path, tool database, the 1/4-inch end mill. Okay, these are from Magnate. They are a set of 3 roundover bits. Most woodworkers know what roundover bits are. If you notice, these don't have a bearing. They're called Plunge roundover bits. If your machine is able to take a 1/2-inch collet, these are great to have for edges in doing plaques and things of that nature. They're also good for spindle work to make beads and coves if you have a lathe attachment on your CNC. And so for me, must have Plunge roundover bits from Magnate. And again, certainly last but not least, what about a starter set? This for me makes all the sense in the world. You've got a 1/4-inch shaft end mill, 2 tapered Ballnose, a 1/8 and a 1/16, and you've got an 1/8-inch end mill, a 90-degree V-bit, and a 60-degree V-bit. And for those that are just getting into the CNC hobby with your X-Carves and your Inventables machines, the DIY put-together kits, etc., these bits right here will get you just about anything you need to do in making a sign, a small 3D model, cutting out a profile, etc. So, great little starter set. Precise bits on the tapered end mills. I think Home Depot, quite frankly, on the V bits, and then the end mills, the 1/8 inch and the 1/4 inch from US Router Tools. So have a look at the list. Go to the manufacturers. Read. There's a lot of great stuff on their websites. And hopefully this video has helped get your bits into Vectric, where you can buy them, and what bits should we get. And hopefully down the road I can do another series on maybe some, bigger bits, different kinds of bits, bigger tapered bits, profile bits, etc. And I want to thank you once again for hanging out with me here for 20 or so minutes. I really appreciate everybody, watching the channel. If there's anything I can do, shoot me an email, comment in the section, give me a thumbs up, all that stuff. I do it for the love of the hobby. Not much more than that. So anything I can do to help anybody, please let me know. Once again, this is Work Against the Grain, and my name is Jeff.